Weather Explainer. Today, we're taking a literal journey inside one of the most magical yet totally misunderstood appliances in our everyday lives. We're going to break down exactly how air conditioning cycles work. If you've ever found yourself sitting there wondering how a simple metal box can seemingly manufacture winter in the middle of July, well, you're in the right place because this explainer is absolutely for you. So, how does your AC actually keep you cool? I want you to really think about what's happening when you press that power button and suddenly feel that icy breeze hit your face from across the room. Fun fact for you, the very first air conditioner wasn't even invented to keep people cool. No way. It was actually built to dry ink in a human publishing house. But what is that machine actually doing behind those plastic vents to manipulate the temperature in your home? Well, to truly understand this, we need to completely flip how we think about temperature and appliances in general. All right, let's jump right into section 1, the Great Cooling Myth. Okay, so the common misconception is that air conditioners somehow manufacture cold air out of thin air, right? Like they're these little ice factories just blowing chilliness into our rooms. But in reality, they don't create cold at all. Instead, an air conditioner is actually a heat displacement engine. It physically absorbs the heat from inside your room and pushes it outside. You aren't pumping cold air in, you're forcefully pushing the warmth out of your house. It's a foundational physics principle, and honestly, it completely changes how we view the whole appliance. Moving right along to section 2, the 4-step refrigerant cycle. Now, the absolute star of our show here is the refrigerant. This highly specialized chemical acts just like a thermal sponge, soaking up heat from your indoor air. Its real superpower, though, is its ability to easily change its physical state back and forth between a liquid and a gas. Without this specific chemical doing its thing, the whole cycle just completely falls apart. Let's see it in action. So here's a high-level map of the microjourney our chemical hero takes to cool down your room. It's a continuous loop made up of 4 distinct steps: evaporation, compression, condensation, and expansion. We're going to break down each of these steps individually right now so you can visualize exactly how that unwanted heat is getting grabbed from your living room and practically thrown right out your window. Step 1 is evaporation. As the liquid refrigerant moves through those hidden coils inside your room, it literally absorbs the heat right out of your indoor air. This energy causes a physical change. It basically boils the liquid into a gas, trapping your room's heat inside it. Next up, we hit step 2, compression. That warm gas carrying your room's heat is now sent directly to the machine's compressor. And the compressor's job is, well, exactly what it sounds like. It forcefully squeezes that gas. By packing the gas into a much tighter, smaller space, it raises the temperature of the gas even higher. And we actually need this gas to be incredibly hot for the next phase to work properly. All right, step 3 is condensation. That superheated, highly pressurized gas now travels to the bulky unit sitting outside your window. Because this gas is now way hotter than the outdoor air, it naturally radiates all that trapped indoor heat out into the environment. As it does this, it cools off just enough to condense right back into a liquid state. And finally, we arrive at step 4, expansion. The chemical is back to being a liquid, but it needs to get icy cold again so it can absorb more heat from your room, right? So the liquid passes through an expansion valve. This valve rapidly drops the pressure, which immediately cools the liquid back down. It's now perfectly primed, icy cold, and totally ready to travel back inside your room to restart this continuous cycle all over again. The indoor heat gets absorbed, squeezed, released outside, cooled, and looped forever. Let's look ahead a bit with section 3, exploring the high-efficiency cooling future. Now, we just mapped out the basic science, but applying these fundamentals to real-world data is exactly where the industry is heading. If you really want to dig into this, you can actually upload a manual for a specific AC unit or review complex technical papers on high-efficiency cooling to deepen your knowledge. By analyzing this kind of stuff, you'll see how engineers are currently optimizing this exact loop. They're discovering incredibly innovative ways to refine the process, saving immense amounts of energy and protecting the environment along the way. Because the future of cooling is happening right now. Advancements in things like variable speed compressors and eco-friendly refrigerants are fundamentally changing how we beat the heat. As global temperatures continue to rise, how will this 100-year-old cycle evolve next to keep us cool without warming the planet? It's a lot to think about, so I'll leave you with this. Would you like to run a fast research search on the latest energy-efficient air conditioning technologies? Thanks so much for joining me on this explainer. I hope you never look at your AC the same way again. Keep on learning.